Hello, welcome to my channel. We will be doing question number 14, chapter 1, mechanics. Okay, this problem is easy. You see, the scenario is that on a road, on a flat surface, there are two cars. So car 1, let me draw it like this. So this is first car and this is second car. And the distance between them is 5 meters. Okay. The first car is going in this direction with a speed of v meter per second, and the second car is going in the same direction with a speed u meter per second. And it is given that u is larger than v, so at some time the distance gap between them becomes zero, and the second car will overtake the first car. Okay, and both of them are deaccelerating with an acceleration of a. So acceleration is minus a meter per second square. Okay. Uh, Now the first part of this problem is that show that the second car overtakes at this time. Okay. Time at which it will overtake is given by this thing. Okay. So you see, I will try to find out the distance traveled by second car as a function of time. So it's going to be the famous formula VIT plus half AT squared. So I will write this formula as the distance traveled by the second car as a function of time. So initial speed of this car was u. So it is ut, and acceleration is negative. So I will say negative 0.5 a t square. So this is the distance uh, traveled by the second car as a function of time. I'm counting, but I'm measuring all the distance from the initial position of the second car, the position at time 0 of second car. Now, in the same way, if I try to write the expression for the distance traveled by the first car as a function of time, again, I will use the same expression. Okay, but remember, the first car is already 5 meters ahead of the second car. So the distance would be 5 plus. Now, VIT is initial speed is VT, and again, it's the same thing minus 0.5 AT squared. Okay, so at some time, these two distances become equal. So S1 of t would be same as S2 of t, and I want to find out that at what time they will be equal. So let me put the first expression or the second expression or both expression equal together. 5 plus Vt minus 0.5. Oh, sorry, I should not say A. It is simply, oh no, it is yes, 0.5 a t square. So this minus, so this is the distance of the, oh, sorry. Okay, I'm sorry, I was a bit confused. So yes, okay, this distance is equal to the distance of ut minus 0.5 at square. So you see, this will cancel with this thing, this straightforward. Okay, and if I bring this VT on the right side, it's going to be 5. This is 5, yeah, oh, sorry. 5 is equal to ut minus Vt. So if I take t common, it is going to be u minus v equals 5. And is it 5 or s? I'm a bit confused. The two column, the first one is s meter ahead. Yes, sorry, this is s. It's not 5. It looks like s, but it looks like 5, but this is s. Okay, sorry. So this is s. Doesn't matter. I just have to uh, take this as s. So this is s, not 5. My 5 will also look like s anyway. Okay, so t is going to be s divided by u minus v. So this was the first part. Okay. Now the second part of this problem, let me change the color. Okay, this is B. Show also that the distance from the starting point of the second car to the point where they overtake depends on A, and find that formula for the distance. Okay, so at this time, right, both distances are equal. So how much are those distances, right? So uh, since this expression is a bit easier, so I will use this one. So the distance of second car as a function of time is equal to ut minus zero point 0.5, or let me write it as oh, the 0.5 is okay. It's 0.5 at squared, right? And what I will do, I will substitute this t for over here, for t over here. So it's going to be u s over u minus v minus 1 by 2 in a and t squared. So this is going to be s squared over u minus v squared. Okay, let me try to simplify this expression. So if I have to add these two fractions, the common denominator would have to be 2 into u minus v squared. So here I have u into s, and the rest I should add 2 into u minus v. Okay, and minus a s squared. So this would be the thing. Okay, now let me open up this bracket. So denominator is 2u minus v squared. And here I have, you can see 2 and s and u squared, right? When you open this bracket, it's going to be 2s and u squared minus 2 uvs, uvs, and minus as squared. Okay. 2su squared minus 2suv and minus, yeah. So this is the thing. This is the distance traveled by the second car, or actually this is the distance at which second car will overtake the first car. Okay. So this is our answer for part B. Sorry. Okay. I hope you enjoyed this question. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.